So what I am going to do is today is I'm just talking about potential of marine organisms, about the marine drugs, and you can see it, there are huge potentials. One of the thing which even Omkar sir, I wanted to ask you about green fluorescent, proteins. One of my students have worked on the green fluorescent proteins isolated from coral symbioid. Coral symbioid zooxanthellid. Without that, coral cannot survive. Zooxanthellid, and the zooxanthellid available in Indian coast. We have isolated it and even did it little bit work. We could not go further. And that's the drawback or limitations of life science, because we cannot go do it at every stage. Student fellowship got over, she completed the PhD, she could not, but potential was identified from that. Okay, can we go to? So there are a lot of marine organisms. I just given one of the examples where we have a possible even the drugs, but compared to the other these things, there are not many drugs, but there are potentials have been identified. And one the proof. Here is the proof. Yes. Yes. Exactly. In fact, with NCL, we have worked on another aspect. We have a patent, 3 patents. I am one of the worker in that, and we did the work of those oyster and mussel shells, and they have been used now in tannery and in the liquor factories to purify their product, because this is used as a filter, like biofilter, but purified form. So there are different type of organisms. I was just talking about it, and they are not as a food in marine organism. Food we all have known, but they have different type of services what they are providing, and they act. When we talk about services, they usually have, for example, multiple services. You can see that scooter, how they are being used it. A small scooter, but full family is being this, and that's how the marine organisms have the potential of surviving everybody. Sponge is one of that species. Sponge itself is an habitat, and there are at least isolated extracts which have huge potential. There are 1 or 2 products in the testing stage isolated from sponge, not a final product. One product has come, I have heard about it, but it is not, and we also have been working on that, on this. And when I was talking about that Rajiv Gandhi Foundation, I got a funding. Basically, it was for the sponge fauna of the Maharashtra coast, because that was a neglected area, and then nobody worked on that. And basically, whoever have worked in a small component was there, and taxonomy was not done properly, because taxonomy was same species was identified at 3 different names, and some of the species were identified that which were not available in India subcontinent. But we know there is a problem in taxonomy, so we don't want to blame each other. There are limitations, and there are people are taking the advantage of that limitation. That also is there. So we did the taxonomy of that, and we used the molecular technique to confirm that whatever the drawback was there in the earlier taxonomy, can we restore it properly. That was the purpose. In fact, I did it for not only the Maharashtra coast, for Indian corals, and we found that almost 30% of coral species identified, published in books, research papers, SCI journal research paper, 30% species names are wrong. 30% coral species names are wrong in India. Finally, we struggled for 2 years. One of my PhD students worked on that one. And then we published the paper. And now that is being one of the highly cited paper, but everybody has to refer that one. There is no other way that, whoever will work on coral, they have to find out that why it is wrong, why. And we try to, identify the problem. It is not identifying somebody's mistake. Identifying the problem and correct it. That is what research means. This is the next slide. Sir, can you, yeah, please. So what I was talking about marine biodiversity is that we are all using it, marine diversity, for food. However, if you look at it in generally, very less have been known all about the marine biodiversity. We know it from food point of view as a food animals, but only few % of that is being used for the food, even less than 5%. Rest of them, they are not, they are the mostly food for others. And also they are not been exploited for any other purposes. Example I gave you about the sponge. Sponge itself is a habitat. It hosts thousands of different species, excluding microbes, because microbes itself will be millions different species. Nobody has identified. And it filters the water. It helps the ecosystem. In fact, sponge works as a aquaguard for the natural system. It filters the water, and wherever corals are there have to be sponge, because corals required purified water, and sponge does that work, purifying the water regularly, continuously. And because it filters the water, it accumulates all the organic material inside. And when there is organic material available, there will be bacterial production. And when the bacterial production, there other organisms, they will come for the feeding, and that's how they colonize the sponge for their different activities. Some are only for feeding, some use sponge for the breeding purpose, because the porous, they can lay the eggs there. Food is available for the baby, so you don't have to go anywhere else. But then again, the sponge have limitations, because mostly the sponge, 99% sponge are the sessile. They require hard substrate to attach. And there is the problem, both from bioactive compound point of view, the advantage and disadvantage is what? Because they are sessile, they are not available everywhere. Because they are sessile, they have to cope with the changing environment, increasing pollution. We can talk about climate change also up to certain extent, but pollution, for example. But that is the advantage, because of the pollution and other pollutants and stress. I can say stress more. Pollution also part of stress. So because of the stress, sponge, symbiont or associated bacteria, those are the ones which are creating this type of compounds for their own survival. And that's how sponge is being used very well globally as a potential material for isolating the bioactive compounds. Well, what I wanted to tell you from this slide is, if you look at it, there are huge potentials of finding the new drugs in the sea. In fact, if you look, I think some of you there was an article published in Nature, and they says that clue for coronavirus could be lying in the deep sea. Okay, and what is it? In fact, presently I am working on associated environment, and what is that is hydrothermal vent. Hydrothermal vent are nothing but the systems where you have seabed is there, wherever you have hard bottom, we have the plate tectonic, what we have been saying is there, and those two plates are meeting each other, but there is a gap, and that gap is always, it's moving. Below that you have the lava in the core. The lava is boiling, and the lava comes out occasionally wherever there is a weaker zone. When it comes out, it brings all the material in the core that include heavy components of minerals. And we are, under the India's new deep sea mission program, we are working on to find out the new mineral resource in the deep sea. So under that program, to find out the new resources, mineral resources, we as a biologist are trying to find out the material. Along with that, what biological material also is available, if at all, and bacterial compounds are potentially source available because they are coming from the core zone. So there is a potential, they say, that the drugs or clue for the finding out the drug for the corona or new this type of disease could be lying in the deep sea. Well, but when we talk about it, I was just mentioning it, we know that 70% of the surface is covered by the earth surface is by water, and of that 50% comes in the deep sea. When we say deep sea, more than 3 kilometers is the deep sea. Rest that what we consider coastal water, and that is 50%. Of that, only 5% have been studied remotely, operating different type of equipments. If you practically talk about it, we have sampled entire sea. If you look at it globally, not even 0.0005% have been sampled, or 1% have been sampled. 0.001% is not practically been sampled, and the reason is it is very expensive. Like sir was talking about, drug discovery is very expensive and lengthy process. Similarly, working in the deep sea is very expensive. You require the deep sea going ships. Ships are very expensive. It is 1,000-2,000 crore one ship, research ship. You will not believe it, but I am involved in that process also. Indian government is going to procure another 2 deep sea vessels now, and we are going for that tendering process and those things. So they are very expensive. And then equipment. For example, we are going mostly in October, November. We are waiting for this corona. Last year we are supposed to go. We have hired a ship from Europe and going for the submersible, where the in future, maybe another 4 or 5 years, we'll be sending the man down like Chandrayaan. We are working in Samudrayaan. So similarly, we are working on that this thing. But initially, we are hiring the different equipment to send the remotely operating equipments, which will go where the lava is coming and collect the sample from there and then test it, as I was just telling you that. So that type of work is done very few parts, particularly that is what I am saying, and very few countries have got that capabilities of doing that type of research work. Next one, please. Okay, and when I say very less has been studied, I just want to give an example so you will easily understand how much. We have an area near Ratnagiri, Maharashtra, between Mumbai and Ratnagiri. Okay, Mumbai here, Ratnagiri here, is the Malvan here, and from Malvan, if somebody has visited Malvan, they'll understand very well. Goa is down here. Here is the area around 100 kilometers in the sea. It is not a deep sea, the coastal water. So it is 100 kilometers from here. If you go from Devgarh or Malvan, it is less than 100 kilometers. So this is the area called Angara Bank. And Angara Bank is like it is in, if you see entire globe and Indian Ocean, deep Indian Ocean, Angara Bank for me, it is like my garden. Okay. That is how the comparison you can do. And this Angara Bank, it is in my garden, but till now, till 2014, we Indians were not knowing anything about it. And that is the limitations when we talk about how much we know about this. And this is the area which is huge area, because we were not knowing anything about biodiversity. I, along with my team, gathered a team, and then funding is required. Ship going is not easy, again, as I was telling you. But luckily we got our own ship. NIO ship was available, and we got the ship. My director agreed for it. I got some funding for United Nations funding, particularly for inventorying the biodiversity of Angara Bank. And under the NIO's banner, we conducted the expedition. This was a diving expedition. I myself is scuba diver, and I think so Mahesh Patil is sitting here. He knows it. In our lab, unless you are a scuba diver, it is very difficult to survive. So that is how we take the student, because scuba diving is a must. Without that, you can't go to field work. And if you can't go to field work, you can't do the work. That's how it is there. So we conducted the work and we came out with a detailed survey of the Angara Bank and then submitted to the Indian government, to the Forest Ministry. Now this is the area which has got more than 200 coral species. So far, what we identified are 150 different fishes, coral associated fishes, around 35 algal species, and all this was not known. Now this is going to be Indian government based on our survey. Subsequently, another survey was conducted, and now we submitted the report to Ministry of Environment and Forest. This is Indian government under the CBD, Convention of International Biodiversity, International Convention. There is because India is a signatory for the CBD, India is committed to preserving India's coast, 30% of the coastal area as a conservative zone, conservation zone. Not exactly as a marine protected area or the protected area, but conservation, 30%. But it will not be possible to do it because so far we don't have any like such offshore conservation zone. So this is based on our work. India, maybe very soon, Indian government will declare this as India's first offshore marine protected area. A huge potential for the drug discovery, because most of the things not touched by human being, hardly only fishermen have gone there, and biodiversity is very rich. Because we conducted a survey only in 40 meters, because beyond the 40 meter, a common diver cannot go. You require different type of system to go below 40 meters for the scuba dive. With the help of equipments, you can do it, but it will damage the coral system. So we don't want to damage, we want to preserve also and come out with the result. So the purpose of this slide to tell you was that is the limit what we have. Even what is there in your garden, you don't know. So how can you, survey the entire ocean? Next one, please. Well, so what I was talking about, the Global Youth Development Program, this is why I'm telling this one, because we have a lot of potential. And one of the things we have is coastal fishery. Now, coastal fishery, when we talk about, we are only using it limited fishery resource for consumption. But there is a potential for also medicinally important properties to extract. And one of this is a fish oil. Again, some of you must have been the beneficiary like Madam did. As a substitute of protein, tablets are given cod liver oil, and it is commonly available. We are not at all producing that direct product. And it is raw material is plenty available, and it is necessity for the country. It is necessary for the country. We need to diversify, look for this type of material which is already known and people are producing it. We are producing raw material, not that we are not producing, but final product, we need to go for that type of thing. That's what I wanted to. Well, we also know that some of the fishes have very high omega-3 fatty acid, such as, for example, sardine, mackerel, which is huge quantity available in India, the coastal water. particularly if you talk about the Ratnagiri to down Trivandrum. We have sardine and mackerel fishery, which we call as pelagic fishery. And all the sardine and mackerel fishery is basically more used for domestic consumption, because we have the lot of need, but lot of catches are wasted, and we are not producing as we required the material from the medicinal point of view. This is the food. Omega-3 fatty acid is used as a substitute, is mixing in the food there, it is used. So we can go for the huge production or increase the production of this one. There is a potential available. That's what I want to tell you. I was talking about calcium, and there are a lot of other organisms, not only the bivalves, but other organisms are also which have the shells. Lobsters, shrimps are being used. Of course, they have a lot of potential, but those shells also have the potential, and it can be used for the different product of the material. And this is what I was just telling about the tablets which are available in the market. Now there is one more thing I want to talk to you is about the fish and its future. And why I'm talking about this fish and its future is there is a huge demand globally for the fish as a food, and it is going to increase because some of the countries, like example I'm giving Europe, if you look at the food demand of the Europe, the first choice of food, you can see the different products here: vegetable, milk, meat, fruit, food, and fish. So color wise, if you see it, green is the food and blue color is the fish. So European preferred fruits and the fish as a first choice. And in the future, if fish is not available, what is going to be the eating that? Fast food is there, na? And it is available in come now in the form of tablet. Which protein tablets will be available to substitute as a fish? And from where it will come? It will come from the countries like India, which has got a huge potential to produce it. Which has a potential to produce it. We have to look for it. Also, there are other potentials in India. Probably I have. Okay. But when we talk about the drugs, I thought I will, use a little bit potential because this is one of the bivalves. There are plenty of other species, but because I work there, my students work there, I know it. We have already patented it. Process patent. It is directly associated with the mangrove. That is why it is called mud crab or mangrove crab. Only there was some work done on this one published form. Hardly anything was done. And accidentally I found this in one of the mangrove area on west coast of India. We went for field work. It was not intended to be. We went for sampling almost this much mud. And when I went there, we found there was some activity in the mud. We went for the biodiversity survey. I thought there is something. Then I told them there is something here. So we dig it. I put my foot there only. I didn't remove it. Dig it and found big shell. Big shell of this plant. Ultimately work on that as a biologist. Curiosity is there. So what is it, from where it comes, what is the history of this, all these things. And finally we published that one. We found that this is one of the shell of the mangrove clam, and it is only available in the mangrove habitat. Then I have a little bit more curiosity. I said, why only mangrove habitat? Then I prepared a proposal, submitted to Minister of Environment and Forest. There also almost 1.5 years it took it But I got some funding from Ministry of Environment and Forest 1995 or 1995 or something like that. Then we did entire of the west coast of India, that where it is available. Where it is, we found it wherever it is there only.
जेवण झाल्यावर म्हणजे 15-20 मिनिटांनी जाते.
About the microbiology, my student from fisheries were knowing about the ecology, and I was in between that, and that's how we wanted to find out the reason. And we did it quite almost 2 years work on that one. And what we got it clue is this clam is such a species, it take part into photosynthetic activity, means directly consuming the food from the phytoplankton and this dead organic matter, but also it has the, in the traces condition, it has the activity. It doesn't take part into that, but it has the activity of chemosynthetic activity. What is it? Nothing but it has the big shell and it survives without water for months together. If it survives without water months together, what happens? It is aquatic, it is not a terrestrial animal. It requires the water. That is why it is aquatic. But it survives without water outside because it holds the water inside. And the inside water is rich in bacterial flora. Those bacteria uses the fecal matter and sulfur, because in mangrove you have got a lot of sulfur available. So bacteria reproduce it in mass, clam feed on that material, and nutrient in the form of fecal matter is supplied to the bacteria. So cycle is completed within the shell, because it is from primary to the secondary consumer. So it is completed within. Then what is that activity is going on is because it is adapted to that condition. And then we came to know that this clam is associated because the mangrove supply that sulfur. Now what we did it next is, because it is an edible clam, so we prepared the extract of this one, and in association with CDRI Lucknow, we found that the clam's extract has an anti-malarial activity. See, where to where we went, found a clam only in the mud and now patented. So that is how now we have not gone beyond that, again, as I told you, because we have our own limitation. If I start, then I'll have to learn ABC of that one. I may not be even get it that. So it is the work of somebody like microbiologist or pharmacologist or drug chemist. They have to take it. The patent is available. You can use the patent. So basic informations are available with National Institute of Oceanography, and you take it forward. Okay, how much time I have? I will go on talking now. So there is 15 minutes. Okay, good. That should be enough. Then I want to talk to you another bivalve species. This is a bivalve species which is again available on limited portions of limited areas along the Indian coast, particularly east coast, 1 or 2 places only. Kakinada it is there. West coast it used to be there, but now it is habitat is shrinking. And this is nothing but the Windowpane oyster. It is a cousin of pearl oyster. It's a cousin of pearl oyster, not a pearl oyster, but it is a cousin of pearl oyster, and it is available in Goa. And we did it a good study of its ecology, because we wanted to restore the habitat. Purpose was restore the habitat. And what we found is that around 2 to 5% of these clams during the ecological study, they have the pearls, natural pearl. And you can see that here is the clam which is dissected. These are the 2 shells dissected, and here you have the pearls, around 15-16 pearls. And like that, I have maybe around 200-300 pearls must be there in the library. These are natural pearls. And natural pearls, if you want to know about it, have been used traditionally in Chinese medicine. Very important. Market value, I don't want to talk to about it as a pearl, natural pearl, but medicinal value. So there is high demand for that if it is available. But the habitat itself is shrinking because of the lot of pressure on the habitat, and we are trying to restore those habitats, some of those habitat with the culture methods. But it has huge potential from the medical point of view. That's what. Sir, you have to help me because this is either is not working properly or I am not using it properly. Yeah. Oh, just go back, please. Again, some of you must be knowing it about the next one, please. About the horseshoe crab. National Institute of Oceanography, we have been working on the horseshoe crab for almost last 3-4 decades. And initially we identified, like I told you about the clams, how it was identified. Although people were knowing it, and in globally, outside people have been using it, horseshoe crab. Horseshoe crab is nothing but it is the oldest, one of the oldest living fossil. Oldest living fossil, even maybe same age like turtles, somewhere around that. Turtle is around 500 million years. This is 450 million years. And since then, the species has not been changed usually much. What is important in this one is the blood of this crab. It is a crustacean. It's a crab. It has a blood which is like any other crab, white color. But that blood, if it comes to contact with the air and water, because air and water nowhere it is unpolluted now. If it comes into contact with air and water, it turns into blue color. The white blood which turns into blue color, and that is the clue is to find out what is the importance of. And from that blood, now the medicine is prepared, which is used for the test called LAL, L-A-L, Limulus amoebocyte lysate. Amoebocyte is the blood cells, Limulus is the species, and lysate is the product. And lysate product is used, maybe some of you know, lysate product, without lysate test, no final certification is given to the medicine to sell in the international market. Domestic market, I don't know about, but international market, all the corona test, all the corona viruses, what we have got it, today, vaccines are developed. Last 3-4 years, we're talking about, our Covaxin or, different type of vaccines, what we have come, all have gone through this test. And today, more than another 20 vaccines, not only for corona, but different type of, are under the trial. And they have to use this crabs, the product, which is lysate, which is called lysate. And it is very expensive. How much? You can see that. $16,000 per liter. That blood, it is not the product. Product will be very expensive. And we did entire ecology, west coast of India, we get it on Orissa, West Bengal, Andhra, part of Andhra, it is available. We did it, the entire study. We don't get the species Limulus. We have got Tachypulus. So the product what we have developed for the testing purpose at the laboratory level, it is TAL, T-A-L, because the species is a Tachypulus, not the Limulus. Limulus is the particularly in the American, Canadian coast, what that species is available. So this is the species available. We have done again more work on the conservation because it is the oldest living creature. On medicinal properties, 2-3 patents are also patented. But again, it has not gone to the product. I don't know why it has not gone. I can't even answer the question why it has not gone, because that is not my area of work. And I told, because patents are available, if somebody wants to pick up it, why some pharmaceuticals are not coming forward? Maybe some lacuna from scientific side also is. When Sigma is selling the product to entire world, and without that test, nothing can go forward. Why are we not doing it when we have it in India? So horseshoe crab, this is how it is. I was just telling you. It lives and it like turtle only it is. It lives in the deep sea. It come to the coast, male and female together for laying the eggs. In the previous slide, I showed you. Usually when they are moving, they're moving together like this. Male and female together. Female is down, male is here, and they move it, come to the coast. And then when they come to the coast, like this, they come on the sandy beaches, dig the nest. Female will lay the eggs there. Male will fertilize the egg. They will close down the nest and then go back to the deep sea. So their eggs will hatch like turtle eggs are hatched. And then with the high tide, these eggs are again washed into the sea and taken into their habitat. Main habitat is the deep sea. More than 200-300 meter water depth they are there. But the reproduction, like turtle only. Turtle also deep sea living species, and for nesting purpose, they come to the beach. Again, what we have done it here in this case is we tried to develop a techniques where, because most of the product what were available are, they were sacrificing the animals. We wanted to save the animal, and if we can bleed it repetitively. So we have to standardize the method like blood donation. A healthy person, how much blood can donate and at what? Also, we were running a program to conserve the species. So sea ranching. So take the eggs from the beaches, bring to the laboratory, breed them, spawn them, and then complete their life cycle as much as possible, and then release, because it will be reduced, and that's how we can have more population. So that is the sea ranching also we were trying to, do it of this. There's another species which is everybody knows about because it is charismatic species, is a seahorse. Seahorse is again very important medicinally, particularly in Chinese medicine. It is very regularly used, and it is used because it is mostly used as a aphrodisiac. It is like Viagra drug, and Chinese are regularly using it in Chinese and it is marketed with that label. It is like Viagra drug, but it is so expensive because of that demand, seahorses globally are vanishing. India has a huge population and market, but in the process, what happened? Fishermen, as all of you know, that fishermen have no limitation. Even when the product is available, they go with all type of methods and catch it and sell in the market. Tomorrow, what happened? Nobody knows. And that's how we have lost the seahorse population. Now, at present, there is a ban, export. Nobody can catch and sell the seahorse unless it is the cultured one. If cultured one is there, then you can sell it for the aquaculture purpose, not for any other purpose. But then when it has got such a huge market, we should also be looking for its propagation. And that's what we did it in NIO. One of my another student, they did the PhD on this one, and we completed it. I don't know, sir, kya ho raha hai isko? This is how it is used in the different medicinal purpose. Next one you can give. So this is how the seahorse male female are shown it here, and this is one of the species where the parental care is very important. And how is the parental care? Like kangaroo, but importantly, female don't have to go for labor pain. It is the male who goes through the labor pain. So female, when the eggs are matured, she will deposit the eggs in the egg pouch which male has got. So it has got the male has got the bag. It is called egg pouch. So she deposits the eggs in the egg pouch. Eggs are hatched there, and then till it is released, only male has to take care of those. Female is free then after that. So next one. So we did the complete life cycle, because so far it was only, we have to collect it from the nature or natural habitat, breed it, and then we did it entire life cycle within the lab, completed that life cycle within the lab and developed the technique for culturing that. Sponges I already mentioned, so I don't want to take more time. We can go to next one, sir. So sponge I already mentioned, I told you, but there is one important thing what I just wanted to mention it here is marine sponge produce up to, because of the microbial group here present, I thought I will just talk about it. They are produced almost more than 800 different type of antibiotics, and there are products, as I told you, at the different stage of the testing already are going on. Even in India also, there are people working on that. Different groups are working on that. But all are working on sponge associated bacteria. And those bacteria producing the properties depend on the habitat, as I already told you that. So same species if it's available in Ratnagiri and same species available in sponge species in Goa may not have the same properties, because the habitat and the stress probably is put it on that one will induce the associated bacteria to go for the survival, and that is how the activity is induced to that one. Next one. Next one. Okay. There are also, just I thought I will just mention it because it is very commercially important. And why it is commercially important? Because there is huge problem all along the coast is about the oil spills, and every year it is increasing. And whenever there is some problem in Gulf, particularly Gulf countries, because oil producing countries, accidents are prone to be there, and you cannot avoid it, because I have worked with the ONGC almost for 15 years on the offshore, Bombay offshore. I know it that whatever care you'll take, your pipeline is underwater around 200 meter down, and it is below the seabed. 200 meter water. Below that, you have the seabed, sand, mud, and that digging, they have put the pipeline to bring the crude oil from the oil well to the refinery. So these are put it in 1980s and 90s pipeline. Now it is 30-40-year-old. Those pipelines are there. They are going to replace and repaired regularly, but there will be some pipeline burst, ship accident, and those things happens. So we are talking only about Bombay High. In Gulf, there are hundreds of Bombay High, not one. That is how they are producing the oil and supplying to the entire world. So what will happen there? The similar problems are there also, and that's why there is a lot of problem about oil spill in Arabian Sea, because Arabian Sea is a major oil transportation linked to the globe, both east and west. Through Arabian Sea it goes, and therefore there's a problem about the oil spill. So we are looking at, different marine scientists are looking at the marine bacterium, which can be, there are already available, but different type of which can be very helpful for degrading that oil. Otherwise that problem is, it is creating natural problem. Fishery problem will be there, environmental problem will there, and if it can be isolated from the marine this thing, it will be easy to apply that. So they are working on that one. This is how I was just telling about Seahorse life cycle, what we have completed in almost 10 years. We worked on that one, and we have that again, the all technique available for rearing them and releasing them back to the sea. So next, go to, I think so we'll finish it now. Next one, please. Go to next one. So coral, I already, one example I gave it about the green fluorescent protein, and there are different again associate And what Sir mentioned already about the Alzheimer coral application are being looked at from, but it is not the coral, it is the associate symbiote. Next one, please. Sponge, I already talked to you. Next one. Okay, I think so. This is my last slide. So different type of products from different type of marine organisms, particularly corals, how important they are. The coral is not edible, but coral reefs are very important for the biodiversity hotspots. And why it is important? Because one small clue is there. If coral is present, that means that environment is clean. That means it is, if it is not entirely pollution free, it is definitely less than the surrounding environment. Otherwise, coral cannot survive if it is polluted or highly polluted environment. So coral can be used as a biological indicator. That is what I wanted to tell you. Thank you very much for the opportunity.
Thank you very much, sir, for your profound knowledge in this area of marine biodiversity. Now, I would like to request Professor S.P. Chavan, sir, to felicitate Dr. Baban Ingole, sir.
So there is no time for the question answer. If there is anything, my email address is there with sir. You can anytime ask me because everybody is waiting for the lunch.
Thank you very much, sir. Now, I would like to request Dr. G.B. Zore, sir, to please introduce our next speaker, Dr. Rakesh Moria, sir, former Chief Scientist and Head Medicinal and Process Chemistry Division, CSIR, Central Drug Research Institute, Lucknow. He's joining with us online. So, sir, please.
So very good afternoon, everyone. I know you guys are eagerly waiting for a nice talk from Dr. Moria sir, and I think I'm here to introduce him. It is my privilege to introduce Dr. Moria, Dr. Rakesh Moria. Before that, I would like to request you all to just wait for maybe 20-30 minutes. He will be finishing that talk within 20 or 30 minutes, but it is very, very important for you all because Professor Moria was supposed to come here, right? But he agreed, and then suddenly he got some health issue, and that's why he agreed to deliver a talk online in hospital a couple of days ago. So it is because of the student. He said he will be delivering the talk online. So I wish you will be enjoying the talk. So I will take this opportunity to introduce him. So Dr. Moria was a chief, currently as an emeritus scientist in Central Drug Research Institute. It is a CSIR laboratory. And he was a chief scientist of chemistry division in the CSIR CDRI Lucknow. So he has a profound this biodata He has a huge experience in drug discovery, 32 years of experience, and out of which he spent a lot of time in Israel, UK, USA, and India doing research on drug discovery. He has published more than 200 publications, 200 papers on drug discovery in the journals of national and international reputes. He worked as a postdoc in several institute abroad, like Germany, that is Henman West Germany Fellowship, to carry out postdoctoral research in the Weizmann Institute. Then he worked in Ramat Gan, Israel. Then also he was working as a research officer at the GM Sterling Department of Chemistry, University of Wales, UK. He also worked in Department of Chemistry, University of Essex, Stocker, UK. He also worked in Virginia State University, USA. He has patented more than 51 technologies. He has got 51 patents on drug discovery. And out of these 51 patents, he has commercialized 6 products. And he has received several awards for his innovation and for his product development. And with this, he worked on different plants like Dalbergia sissu. Some of these products are like osteogenet, that was developed from Butia monosperma, that is we call Palas. He has also developed another product from the plant Ulmus wallichiana, and that was again commercialized. He has developed another product from the Dalbergia sissu extract from the rapid fracture healing agent. He has developed another product called Reunion, and it was commercialized with the help of Pharmacia Herbal of the Lucknow. Osteoarthritis is another Dr. Lal Hingorani, right? Dr. Pharmacia Herbal from the Kania, Gujarat. So he has developed several products and commercialized several products, and it is available in the market. So I wish you will definitely enjoy the work Professor Maurya has carried out at the CDRI Lucknow. So with this, I would like to request Dr. Maurya sir to start his presentation.
Professor Jore,
Yes, sir.
please go to my slide, first slide.
Yes, sir. We are doing that. In a moment, we'll do it, sir. Like you may have to share it. You can see, sir, slide.
Yes, I can see.
Okay, thank you, sir.
Okay. Thank you, Professor Jore, for kind introduction. I'm grateful to, are you able to hear me? Are you able to hear me?
Yes,
I'm
sir.
grateful to
Yes, sir. Yes, sir.
organizers. Okay, thank you. I'm grateful to the organizers and in particular Professor Jore for giving me the opportunity to share some of our research works. I could not make it because of some health problems. I wanted to come, but due to some health problem, I was unable to reach there. But I would like to share some of our research work today. Over the past years, we have been engaged in clinical studies of Indian medicinal plants. The major objectives of these studies were the isolation and characterization of compounds responsible for biological effects of the plant, search for the presence of these bioactive compounds, and study of biologically inactive but chemically and structurally interesting compounds of the plant. So, in today's presentation, I will discuss the application of traditional knowledge in search of potential leads for the drug discovery. May I have the next slide, please? Use of plants as a medicine goes back to the early men. Throughout the ages, humans have relied on the nature for their basic needs for the production of foodstuff, shelter, clothing, means of transportation, fertilizer, flavor and fragrance, and medicine. Thus, the plants have formed a sophisticated traditional system of medicine that have been in the existence for thousands of years. The great civilization and, for example, Ayurveda, Chinese, and these medicines were available since long. There's another very good example that you can see here in the picture, that when Lakshman got unconscious in the battlefield and Hanuman brought the medicine from Kishkinda Parvat and Dronagiri Parvat, and that helped to him to save his life. And this gives the inspiration to work on the plants and see the use of plants were long back in the history. Next slide, please. See, another best example, that is in Samudra Manthan, lot of things were churned up along with two chemical compounds, that is Amrit and poison. So this also gives the impression and initiation to work on these marine plants to isolate novel molecules. And the elegant review was just now presented by Professor Baman Ingole. He has given the elegant review on the plant products, on the marine products, which is being used in the nature. Next slide, please. So I have classified the use of herbal medicine into three phases. The first phase, that is when all the people they used to treat their ailments only by crude plant products. And this has been mentioned earlier and by in Charak Samhita, Sushrut, and in Siddha, Unani medicine, and even in Chinese medicine. So this is in the first phase where all the ailments were treated only by the crude plant products. Next. Next slide, please. The second part, that is the second phase, in the early part of the 19th century, attempts were made to isolate the active principles from the plants of medicinal value. For example, Papaver somnifera, morphine was isolated in 1805. And similarly, all these compounds, which has been shown in this slide on left side, were isolated. But the structure of these compounds were established only in the 19th century. We have published this work as a herbal medicine. This was request from elsewhere to write on what is herbal medicine. So we have published, the reference has been given here. Next slide, please. That is the third phase, beginning of the new era in natural product research. The first landmark was the isolation and structure determination of reserpine from Rolfia serpentina, an Ayurvedic drug for hypertension and insomnia. This was introduced as a anti-hyper agent in 1953. This stimulated the research in natural product as a source of new medicine. The second landmark was the isolation and characterization of vincristine and vinblastine from Catharanthus roseus. This plant was earlier used for treating the diabetes, but when these two compounds were isolated and again re-investigated, were found that this is the very good for treatment of anti-cancer. Next slide. So what is the present interest in the drug of plant origin? That is the initial step in the discovery of plant is for identification of new drug. That is the lead identification. If you can find lead molecules, then can be developed into the products by studying several steps, which has been described by the first speaker, that it requires a lot of studies. Next slide, please. So this is the meeting is being recorded. This is another very good example of aspirin, which is used all over the world. This is the first example of isolated compounds from plants, which is in the market throughout the world. This is aspirin. Every one of you have used this molecule, and this was isolated from Salix alba. So you can see this, the most popular medicine, that is aspirin, which is used throughout the world. Next slide, please. Another few examples here I'm giving, that is recently approved plant drug derived from, like artemisinin. This was derived from Artemisia annua. This is Chinese, from Chinese plant. Another Taxol. This is isolated from Taxus brevifolia. And another two molecules, etposide and tenposide. These were derived from the 4-dexmethoxyepidophylotoxin glycoside. This was first isolated in minor amount, and this was further converted into etposide and tenposide. And these are the anti-cancer drugs. So you can see the importance of the medicinal plant. Then they can provide a lot of molecules which are useful to treat the diseases. Next slide, please. So now what we have done, we have also worked on some medicinal plants where we have isolated some molecules for stress, diabetes, and osteoporosis activity testing. Next slide, please. I will give in brief. Next slide, please. Next slide, please. Please go back. Okay, okay, next. Okay, this is good. And for working on these plants for isolation of anti-stress, anti-diabetic, and osteoporotic molecules, we adopted the following methods. That is, first is the collection of the plant material. Well authenticated plant material is done by botanists, and extract is prepared, and this extract is biologically evaluated. Then the biologically active extract is taken up for the fractionation into hexane, chloroform, butanol, and water. And these fractions were again biologically evaluated, and the active fraction is taken up for bioassay guided separation of active molecules. If once active molecules is isolated and its structure is identified, and it can serve lead generation, markers for standardization, biochemical and pharmacological tool, and this active molecule can serve for drug development, and the pure compound or fractions containing compound can be developed as a commercially. So this is the process which we follow for development of our products. Next slide. Now, first, that is the selection of the plant materials. How we go for selection? We select directly from biodiversity, and that is the random selection. We bring the plant material, we do identify and prepare the extract and do the biological activity. Or the informations we can get from Ayurveda, Unani, Siddha, or Chinese medicine, or information cited in ethnomedicine or folklore. These are the methods that we have followed for identification of plant material for our research purpose. Next slide, please. So, stress. We all face stress in our day-to-day life. Stress is the sum of the biological reactions of body to stressors or stimulus. It may be physical, like early menopause, starvation, insomnia, exertion, day-night reversal, aging, or psychological, unemployment, financial problems, competitive life, disagreements, or external like pollution, weather, noise, and traffic, internal like chronic diseases. All these factors tend to disturb our organism balance and homeostasis. And these systems, these stresses are self-limiting and adaptive. However, if the stress events overrides certain threshold limit, changes becomes irreversible and gets pathological in nature. Next slide, please. And it causes heart disease like coronary heart disease, hypertension, gastric problem, diabetes, lungs like asthma, even skin diseases, reproductive dysfunctions like menstrual disorder, sexual dysfunctions, psychiatric problems, anxiety, depression, migraine, immune suppression. So all these problems occurs when there is stress. Now there's need to identify plants or find out some alternative source which can give relief or treat some of these stress diseases. Next slide. So in order to find such a plant, where we can work. Then we look the Ayurvedic literature and we look the Charak Samhita. And in Charak Samhita, there is chapter described Rasayana drugs. What is meant by Rasayana drugs? That is the use of Rasayana drugs. One obtains longevity, maintains youth, improves memory, protect against diseases, lustrous complexion, and strength of a horse. And there were a number of plants described over there. We looked at and then we found around 35 such medicinal plants. We collected them, screened them, and number of plants have shown anti-stress activity. So just for example, I will show you the anti-stress activity of Osmum santum, that is Tulsi, we have selected and worked. We have worked on 35 medicinal such plants on stress, but I'm giving you example of only one example. Next slide, please. So this experiment was done by the biologists. They subjected the animals to stress and acute stress and chronic unpredictable stress models. And after giving stress, blood was collected, and these were again estimated for their activity testing. Next slide, please. So these are the stress protocols were given to the animals, like immobilization, swimming, isolation, soil test, day-night reversal, fasting, forced exercise. These are the stress protocols were given to the animals every day or alternate days. And this helps in our studies. Next slide, please. So we prepared the extract, Osmum santum extract, and this extract was further fractionated into dichloromethane extract, that is C003, and ethanolic extract. And this ethanolic extract was further fractionated into butanol soluble fraction and aqueous fraction. So these four fractions and along with ethanolic extract were evaluated for stress protocols. Next slide, please. So you can see here the non-stress animals, they have all these values. On giving stress, there is significant increase in these values. Their adrenal gland weight increases, spleen, ulcers increases, glucose increases, and creatine kinase decreases. And on giving our dichloromethane fraction, ethanol extract, butanol soluble fraction, and aqueous fraction, this butanol soluble fraction brings back to the normal condition. You can compare this value with the non-stress animal values. So this shows that our bioactive constituents have been concentrated in butanol soluble fraction. Next slide, please. Next slide, please. So we wanted to see what type of molecules are present in butanol soluble fraction. So again, this is the chart which describes that we have isolated 12 compounds from butanol soluble fraction and 2 compounds from dichloromethane soluble fraction. And next slide, please. So these are the molecules that were isolated from butanol soluble fraction. The structure of all these compounds were evaluated by studying its chemical transformation and by its physicochemical analysis, by studying NMR, mass, and other details. So all these compounds belong, see the beautiful structures were shown here. And these compounds belongs to the flavonoid class of compound, flavonoid glycoside class of compounds. Next slide, please. Another set of new compounds. All these compounds are novel compounds isolated from these plant, that is butanol soluble fraction of Osmium centum. All these are novel compounds, first time reported by us. Next slide. And this, when all these compounds were evaluated for anti-stress activity, and these compounds, only out of 14 compounds, 12 compounds from butanol salt fraction and 2 compounds from dichloromethane fractions were evaluated in acute and chronic stress models. And out of that, only these 4 compounds were found to effective. This brings back to the normal conditions when given to the animals of stress animals. So these are the novel compounds. We have given name osmoside A, osmoside B. So next slide, please. So thus, osmium centum leaves is an ideal anti-stress agent for use in the prevention and treatment of human stress-related ailments. So if anyone has any stress, they can drink this osmium centum leaf several times and they will be free from stress. You can write down my email number and you can ask any questions on this osmium centum. Next slide, please. Diabetes, another example which we have worked on the development of diabetes. And everyone knows what is diabetes. I'm not going to describe it here. Next slide, please. Next slide, please. Again here. So first, I want to show you that metformin, which is used by throughout the world, this was derived, this metformin, from compound galangine. And this galangine was isolated from Galanga officinalis plant. And so you can see the drug which has been modified from galangine to metformin is also the example of plant-derived molecules. Next. We have worked on 90 medicinal plants for anti-diabetic studies. And from there, number of compounds which have been isolated and tested for diabetes activity. But here I will give the example of only Pterocarpus marsupium. Next slide, please. Pterocarpus marsupium, in Hindi, it is known as Vijay Sar. In Ayurvedic shops, if you go, you can find out the glass available from this tree. This glass is made from this trunk. You can fill up the water in the evening and drink in the next morning, and this decreases the blood sugar level. So we wanted to know what is the molecules, which are the molecules that are responsible for decreasing the blood sugar level. Next slide, please. So we collected this Vijay Sar trunk plant material, and we prepared the extract exactly mentioned in Ayurveda. Boiled water, and which is mentioned here. Next slide, please. We prepared aqueous extract. like boiled with water in the ratio of 1:16, reduced to 1/4 volume, and this decoction is filtered and dried. And we have found that this extract shows anti-hyperglycemic activity. We have isolated 21 molecules from this compound. Next. And these compounds, all these compounds are new, reported by us from this Pterocarpus marsupium. And all these compounds, we have named it marsupsin, pterosupal, pteroside, marsuposide, pterocarposide, pteroioside, vigioside, vigiosine. All these compounds are novel, reported by us, and these compounds belongs to the flavonoid C glycosides. C glycosides are very rare molecules in nature, and these were present in Pterocarpus marsupium. We have published number of papers, and we have filed 5 international patents. Next slide, please. Along with this novel compounds, we have also isolated number of known molecules from these, and all these molecules belongs to the flavonoid class of compounds. Next slide. So all these compounds were evaluated for their biological activity, and these molecules, pterosupal, pteroside, vigioside, marsuposide, have shown anti-hyperglycemic activity, which was shown in the earlier slide. That percentage was written below the structure. And what we did, we wanted to, before clinical trial, so we prepared the extract, and using HPLC method, we have standardized them using these bioactive molecules. Next slide, please. And these extracts were tested on, given to the, for clinical trials, were done in these 4 medical colleges of our countries. Next slide, please. And you can see 93 patients were taken up, and if from this data you can see there's significant decrease in the blood sugar level in 93 patients in 12 weeks on giving this formulated extract having this biological activity and with bioactive compounds. Next slide, please. Next slide, please. So another example, that is the development of drugs for osteoporosis. Osteoporosis is a serious public health problem. It is one of the major problems in our aging society. Osteoporosis results in the bone fracture in the older member of the population, especially in postmenopausal women. The quality of life is greatly impaired in persons with severe osteoporosis, not only because of their pain and deformity, but also because of their limited ability of movement and fear of breaking more bones. Osteoporosis occurs when bone loses its maximum amount of its mineral content, particularly calcium. Bone is a living tissue that constantly being renewed in 2-stage processes called formation and resorption. In resorption stage, old bones are being removed by the cells is called osteoclast. And in formation stage, that is, the bones are formed by osteoblast cells. During our lifetime, the speed of these 2 processes varies. Next slide, please. That is when we are in the case of childhood, that is below the age of 30. Here the osteoblast activity is more. And so this is the time one should collect the maximum bone. Between the age of 30 to 50, both men and women, they lose bone and make bone at the same rate. So there's no problem here. But the problem starts when women, they stop producing bone protecting hormone that is called estrogen, and their bone becomes perforated. And they lose significant their bone. And there's only one option left, that is treatment of HRT or raloxifene and bisphosphonate. But on using these is very expensive, but it cannot form the bone. Another case, that is both men and women over the age of 65, they lose bone because their osteoblast activity is less. So bone becomes thin and becomes very chance for breakage. And the only drug, that is parathyroid hormone, is available. And this parathyroid hormone is given only through injection and only for 1.5 years, not more than that. And that too is very expensive. So there is need to find out some alternative source for treating such types of osteoporosis. Next slide, please. So these are the current therapies and activities. Next slide, please. I'm not going to explain this. Next. So we look 45 such medicinal plants which has been described in our Ayurvedic literature, and we have worked on number of plants. We have worked on 45 plants, and here I'm giving you example, just only few. That is, one of the example is Butea monosperma, which is also known as flame of the forest. During blooming time, you can see this is like a flame. If you go to the jungle where number of plants are available, this looks like a flame. And aqueous paste of this plant, this bark, is used for treating the fracture healing. And we thought that if this bark is used for fracture healing, we wanted to know what type of molecules that is responsible for giving such types of activity. Next slide, please. So we prepared the ethanolic extract of this Butea monosperma bark, and see, this was given to the animal. This is the vehicle animal, and on giving our ethanolic extract, on the right side you can see yellow marking. There is 37% increase in the bone surface area. So on giving this ethanolic extract to the animals, there's significant increase in the surface area bone. So there's new bone formation. Next slide, please. So we wanted to fractionate this. This ethanolic extract was fractionated into hexane soluble fraction, acetone soluble fraction, and acetone insoluble fraction. So all these fractions were again evaluated in animals to see where the activity is concentrated. Next slide, please. So you can see the yes, the butyl. When this was given ethanolic extract at the dose of 1 kilogram per kg weight, there is significant improved in the bone formation. But when our butanol, that is acetone soluble fraction, was given at the dose of only 50 milligram. So compare from ethanolic extract, this was 1 gram, and from 50 milligram, and you can see the bottom right side figure, there's a lot of improvement in the bone, and there's around 33% new bone surface area is formed. So our activity was concentrated, our active molecules are concentrated in butanol, this acetone soluble fraction. Next slide, please. So from this acetone soluble fraction, we have isolated 23 compounds. Next. And all these 23 compounds structures were evaluated. This is isolated, all 23 compounds, not very easy to isolate and characterize these compounds. So all these compounds belongs to the isoflavonoid class of compounds. And next slide, please. When these all 23 compounds were evaluated in vitro in alizarin red staining activity, and out of 23 compounds, only 5 compounds, that is medicarpine, casein, isoformaldehyde, and formaldehyde and claridine, only these 5 compounds were found to be effective in bone formation. This is the greater the color, that is red color, that is the indication of new calcium formation. Next slide. So out of these 23 compounds, 5 compounds were evaluated in vitro and in vivo also. So only these compounds were effective compounds from Butia monosperma. Next slide, please. So this Butia monosperma that is useful in the osteoporosis, treatment in the osteoporosis, for higher peak bone mass, in fracture healing, promotion of new bone formation. Next slide, please. This product that was licensed to one of the Indian drug, that is natural remedies, which is in Bangalore. This briefly I will describe, that is Almus wallichiana. This is another plant which stem bark was used in the treatment of bone, fracture bones, to heal the fracture bones. So we were also interested to find out which are the molecules. Next slide, please. Just I will show you this extract was further fractionated. Next slide, please. And this only the butanol soluble fraction was found to show the improvement in bone mineral density. And next slide, please. And this from butanol soluble fraction, we have isolated 8 molecules from this plant. Next slide. And all these new compounds, this is the plant first time we have worked on its chemistry. So far, there was no report on this plant. And we are the first person to report and isolate all these flavonoid C glycosides. And out of these, 3 new compounds were totally new compounds we have reported, and we have published this in several publications. And all these compounds were evaluated for osteoporotic activity. Next slide, please. And these compounds were evaluated both in vitro and in vivo. One of the compound we have licensed to chemistry, one of the company which is in USA in $1 million. This is one of the compound that is K058. We have labeled it, coded this with K058, and they want to develop this as a single molecule for treatment of this fracture healing. Next slide, please. Another example that is we have developed a product reunion from Dalbergia sisal leaves. Next slide, please. So using our earlier method, we have also isolated 16 molecules from this. Next slide. And out of this, go back, 16 molecules. Yes, okay. So this is the extract, that is our butanol soluble fraction. You can see this significantly improved. The second last picture, you can see significantly improved in the bone formation when given to the over-optimized rats. So at the dose of 100 milligram per kilogram body weight. So there's significant formation of bone. Next slide, please. So all these compounds were evaluated. Next slide, please. These also another set of compounds which are isolated, and this is one of the isoflavonide diglycoside, which is shown in the blue ink. This is the novel molecules which is responsible for improvement in the bone formation. This is the novel molecule we have isolated, characterized from this plant. Next slide, please. So this is our new molecule which serves in the standardization of our drug reunion. Next slide, please. This is the drug which is available in the market. We have licensed this to one of the company which is in Ahmedabad, is known as Farmenja, and this product has been manufactured and used for repairing the bone. And this reunion, next slide please, product is useful and it can repair in 21 days to 28 days. So a normal fracture healing takes around 3 months, but with our product, it is only 21 to 28 days. Next slide, please. Next slide, please. Another product we have developed for from palak, that is Spinacia oleacearia, for joint osteoarthritis. If you have problem, if one has problem in their joint for cartilage repair, this is the product we have developed from Spinacia oleacearia, that is Desi Palak it is called. We have licensed this product to Farmenja, and this product is also available in market for treatment of joint. Next slide, please. That is for cartilage repair. Next slide, please. Next slide. Just go back. Yes. We have studied around 45 medicinal plants, and we have found the activity in number of plants, but these 5 plants, we have licensed this product, and 2 of our products which are in the market, that is one for fracture healing and that is for osteoarthritis. Next slide, please. And this work was done by our PhD students. These 22 students have received PhD under my guidance. And this work was done in collaboration with the biological group of CDRI, that Dr. Chattopadhyay, Dr. Gautam Palit, and Dr. Srivastav, and Dr. Ritu Trivedi. I forgot to write name, this Dr. Ritu Trivedi. So I'm grateful to all these students and scientists who can given me the opportunity to share this our research work. Next slide, please. Next. Thank you very much for your kind attention. Once again, I'm grateful to the organizers and Professor Jore for giving me the opportunity to share some of my research work. Thank you very much. I'm happy to take the questions. Thank you. Are you able to hear me?
Sir, yes, sir.
Yes.
Thank you very much, sir. Thank you.
Okay.
Now, I would like to request all the guests and participants to enjoy lunch at School of Life Sciences. And we will start the next session at sharp 3 p.m. because we are already getting late. So you guys enjoy lunch and sharp come at 3 p.m.